This is mathheals.com if you want to come here to find more links to YouTube math videos. This is rational equations. So let's take a look at our first one. We got negative 3 over x minus 7 equals 5 over x plus 7. And I want to solve it, and then also want to check our answers, which we'll talk about. This is solving rational equations. Our first step is to factor all the denominators. So factor all your denominators. Well, this problem is pretty easy. There's nothing to factor here. X minus 7, x plus 7, can't do anything with. So step 2. Figure out the LCM and multiply everything by it. So let's do that. I'll start with my first factor, the x minus 7, and I'm looking for the greatest number of x minus 7s in any single denominator. There's 1 here, there's none here. So the greatest number of x minus 7s in any single denominator is 1. I go to my next factor, the x plus 7. I'm looking for the greatest number of x plus 7s in any single denominator. There's none here, there's 1 here. So the greatest number of x plus 7s in any single denominator is 1. So this is our LCM, and this is what we'll multiply our fraction on the left side by, and we'll multiply the fraction on the right side by it. Well, over here, this x minus 7 cancels that x minus 7, and over here, this x plus 7 cancels that x plus 7. And we're left with negative 3 times x plus 7 equals 5 times x minus 7. Negative 3 times x is negative 3x. Negative 3 times 7 is negative 21. 5 times x is 5x. 5 times negative 7 is negative 35. Step 3 says to solve. Actually, let me go ahead and put solve for x in there. Well, that's pretty vague. Solve, that's what we were doing originally. But at this point, it may be a quadratic or it may be a linear equation. So you have different techniques for that. This is a linear equation, so we want to get everything with an x on the, well, get rid of parentheses, get rid of fractions. We got those. Get everything with an x on one side, numbers on the other. So I'll take 5x to the left side and negative 21 to the right side. So we get negative 3x minus 5x is equal to negative 35 plus 21. Well, combine together like terms at any step. Negative 3x, negative 5x is negative 8x. And negative 35 plus 21 gives us negative 14. Yeah, negative 14. Divide both sides by the number in front of your x. So we'll divide both sides by negative 8. And these negative 8s cancel. Negative divided by negative is positive, and then 14/8 reduces to 7/4. And step 4, semi-check your answer. It's a weird way to put it, I know. But what we want to do is we want to ensure that our answer doesn't cause a 0 in any denominator. 7/4. If I plug that back up here, 7/4 minus 7, I don't know what it is, but it's not 0. 7/4 plus 7, I don't know what that is, but it's not 0. So x equals 7/4 is our answer. Let me show another problem. This one we got 2 over x plus 3 plus 7 equals 1 over x plus 3. Well, step 1, factor all of your denominators. There's nothing to factor here. So step 2, figure out your LCM. Now look at our first factor, the x plus 3. And I'm looking for the greatest number of x plus 3's in any single denominator. Well, there's 1 here, there's 1 here. So greatest number of x plus 3's in any single denominator is 1. So that would be our LCM. And that's what we multiply everything by. Now when I say everything, I'm talking about this fraction will be considered one fraction plus 7. So the plus separates them, minuses separate them, and equals separate them. So we're going to multiply it times the first fraction. We'll multiply it times the 7. And the equals also separates it, so we'll multiply it times the fraction on the right side. So x plus 3's cancel, x plus 3's cancel there. And here we have 2 plus 7 times x is 7x, 7 times 3 is 21, equals 1. And we want to solve for x. I think that was step 3. Well, this is a linear equation. 2 plus 21 gives us 23, equals 1. Get everything with an x on one side and numbers on the other, so take 23 over. 1 minus 23 is negative 22. Divide both sides by 7. And I get x is equal to negative 22 over 7. And let me double check all my work here. Creating videos all day, my mind's becoming a little... I probably should have stopped it a couple hours ago, but... Okay. Now remember we need to semi-check our answer. If I put negative 22 over 7 up here, well, it doesn't give me 0, and same there. So that's our answer. Seems like that's really close to like 21 over 7. But let's see if I got my signs all right. Yeah, it looks right. Okay. Let's look at our next problem. Okay, we got 5 over x minus 1 minus 2 over x minus 9 equals 10x minus 2 over x squared minus 10x plus 9. Well, first step is to factor all of our denominators. X minus 1 we can't do anything with. X minus 9 we can't do anything with. X squared minus 10x plus 9, that's the PSD method. So this becomes 5 over x minus 1 minus 2 over x minus 9 equals 10x minus 2 over x minus 1 times x minus 9. Well, step 2, figure out what our LCM is. I'll start with the first factor, x minus 1. I'm looking for the greatest number of x minus 1's in any single denominator. There's 1 here, none here, 1 here. So greatest number of x minus 1's in any single denominator is 1. Again, we don't count how many there are. We're looking for the greatest number in a single denominator. Then I go to the x minus 9. And I'm looking for the greatest number of x minus 9's in any single denominator. None here, 1 here, 1 here. So it'd be 1. So this is our LCM. And this is what we'll multiply everything by. So we'll multiply it times our first fraction. Multiply it times our second fraction. And you can put it before or put it after. I didn't want it to get messed up with that negative that was already there. And multiply it times the fraction on the right side. Okay, let's see what cancels. Here these x minus 1's cancel. Here these x minus 9's cancel. Here these x minus 1's cancel, and these x minus 9's cancel. So we're left with 5 times x minus 9 minus 2 times x minus 1 equals 10x minus 2. And now we want to solve this. This is a linear equation. 5 times x is 5x, distributive property. 5 times negative 9 is negative 45. Negative 2 times x is negative 2x. Negative 2 times negative 1 is a positive 2. Equals 10x minus 2. Combine together like terms in any step. We got 5x minus 2x. That gives us 3x. Negative 45 plus 2 is negative 43. Equals 10x minus 2. Okay, get everything with an x on one side and numbers on the other. So I'll take this over to the left side and take this over to the right side. So we got 3x minus 10x equals negative 2 plus 43. That gives us negative 7x equals, what, 41? Last step, divide both sides by the number in front of your x. So divide both sides by negative 7. And we get x is equal to negative 41 over 7. Now let me double check myself. And so 5x minus 45, 9 there, okay. Negative 2x plus 2 equals 10x plus 2, so that's 3x minus 43, and then get out over there, negative 7x, 41, yeah, all looks good. Now, last step, check to make sure it doesn't cause a 0 in our denominator. Negative 41 over 7, negative 41 over 7 minus 1, don't know what it is, but it's not 0. Negative 41 over 7 minus 9, don't know what it is, but it's not 0. And since this denominator is a product of these other two, you don't need to check it there. So our answer is negative 41 over 7. And let's look at our next problem. Okay, we got negative 8x plus 36 over x plus 3 plus x equals 5. Step 1, factor all of our denominators. There's nothing to factor here. We just got x plus 3. So step 2, figure out our LCM. We only have one denominator, so that is our LCM. So we're going to multiply everything by x plus 3. When I say everything, I'm talking about what's separated by pluses and minuses and equals. Now this fraction is considered 1, so I'm going to multiply it times that. Now this plus separates the x, so I'm going to multiply it by the x also. And over on the right side here, I'll multiply it times the 5. So here the x plus 3's cancel, and we got negative 8x plus 36. X times x is x squared, x times 3 is 3x, 5 times x is 5x, and 5 times 3 is 15. And we're solving this now. So we'll combine together like terms in any step. Negative 8x plus 3x is negative 5x plus 36 equals 5x plus 15. Now since we have an x squared, that means we want to get everything over one side, 0 on the other, and see if we can factor it. So I'm going to take the 5x plus 15 to the left side. So I get x squared minus 5x. And when I take the positive 5x over, it also becomes a negative 5x. Plus 36, and I take 15 over, it becomes a negative 15. Combine together like terms. Negative 5x is negative 10x. And 36 minus 15 gives us 21. Now we can factor the left side. It's the PSD method. Factors as x minus 3 times x minus 7 equal to 0. Now zero factor property says you get 0 on one side, you factor the other side, you're going to set each factor equal to 0. So I'll set x minus 3 equal to 0 and x minus 7 equal to 0. And solve it. Take negative 3 over, it becomes a positive 3. Take negative 7 over, it becomes a positive 7. And step 4 is semi-check your answer. Well, if I put 3 in here, 3 plus 3 is 6. That doesn't give us a 0 in denominator, so that answer is fine. 7. If I put 7 in here, 7 plus 3 is 10. That's not 0, so that's also fine. So those would be our two answers. Grab a drink, and then we'll solve this next one. Okay. Number 5. We got 3x over x plus 5 equals 2x plus 4 over x plus 4 minus 11x plus 40 over x squared plus 9x plus 20. First step, factor all of our denominators. X plus 5 can't do anything with, x plus 4 can't do anything with, but x squared plus 9x plus 20 is the PSD method. So we get 3x over x plus 5 equals 2x plus 4 over x plus 4 minus 11x plus 40, and then this factors as x plus 4 times x plus 5. Step 2, figure out your LCM and then multiply everything by it. Well, let's look at our first factor here. We have x plus 5. We're looking for the greatest number of x plus 5s in any single denominator. There's 1 here, none here, 1 here. So the greatest number of x plus 5s in any single denominator is 1. Then I look at my next factor, the x plus 4. I'm looking for the greatest number of x plus 4s in any single denominator. There's none here, 1 here, 1 here. So the greatest number of x plus 4s in any single denominator is 1. And we'll multiply everything by this. So we'll multiply it times the first fraction. This is our LCM. Multiply it times our fraction on the right side. And we'll multiply it times this last fraction. There we go. Okay. So now the x plus 5s cancel here. The x plus 4s cancel here. The x plus 4 cancels here. The x plus 5 cancels there. So we're left with 3x times x plus 4 equals x plus 5 times 2x plus 4 minus, and we have to put parentheses around this because that negative has to switch the sign to both of those. Okay, 3x times x is 3x squared. 3x times 4 is 12x equals x times 2x gives you 2x squared. X times 4 gives you 4x. 5 times 2x gives you 10x. And 5 times 4 is 20. And again, that negative flips the sign of everything inside. So we're going to get a minus 11x minus 40. So we got 3x squared plus 12x equals 2x squared. 4x plus 10x is 14x minus 11x is 3x. 20 minus 40 gives us negative 20. Now we need to get everything over one side and see if something will factor. And I'd like the x squared to be positive, so I'm going to take these 3 on the right side over to the left side, switching their signs as we move them over. And also I'll arrange them in standard form. So the 2x squared becomes a negative 2x squared. The 3x becomes a negative 3x. And the negative 20 becomes a positive 20. Well, 3x squared minus 2x squared is x squared. 12x minus 3x is 9x plus 20 equals 0. And this factor is using the PST method. So it factors as x plus 4 times x plus 5 equal to 0. Now, zero factor property says you get 0 on one side and you factor the other side, you set each factor equal to 0. So I'm going to set x plus 4 equal to 0 and x plus 5 equal to 0. And we get negative 4 and we get negative 5. Somewhere I started solving for x, that was step 3. Okay, there you go. Now, step 4, semi-check your answers. If I put negative 4 back up here, negative 4 plus 4 is 0. We can't have a 0 in the denominator. So that one crosses out. Negative 5. If I put negative 5 here, negative 5 plus 5 is 0. We can't have a 0 in the denominator. So that one goes away. Since both of them went away, our answer is no solution. Let me start a new document and look at the next problem. Grab a drink also. Okay. See, in this problem, we got 3 over x plus 6 plus 20x minus 57 over x squared plus x minus 30 equals x over x minus 5. Step 1, factor all of your denominators. X plus 6 is okay, x minus 5 is okay. This one is the PSD. So we got 3 over x plus 6 plus 20x minus 57 over x plus 6 times x minus 5 equals x over x minus 5. Step 2, figure out our LCM and multiply everything by it. I'll go to my first factor, the x plus 6. And we're looking for the greatest number of x plus 6's in a single denominator. There's 1 here, none here. So the greatest number of x plus 6's in a single denominator is 1. Then I go to my next one, the x minus 5. And I'm looking for the greatest number of x minus 5's in a single denominator. There's none here, 1 here. So the greatest number of x minus 5's is 1. So that's our LCM, and that's what we multiply everything by. Multiply it by the 3 over x plus 6. Multiply it times the 20x minus 57 over x plus 6, x minus 5. And we'll multiply it times the x over x minus 5. Now let's see what cancels. The x plus 6's cancel there. The x minus 5's cancel here. The x plus 6's cancel there. And over here, the x minus 5's cancel. And we're left with 3 times x minus 5 plus 20x minus 57 equals x times x plus 6. And we want to go ahead and solve this. So get rid of parentheses. 3 times x is 3x. 3 times negative 5 is negative 15. Plus 20x minus 57 equals x times x is x squared, x times 6 is 6x. Combine together like terms in any step. 3x plus 20x is 23x. Negative 15, negative 57 is negative 72. That's 10, 12, yeah, negative 72 equals x squared plus 6x. Now since we have an x squared, we want to get everything over one side and 0 on the other, and then factor it. So I'll take the 23x minus 72 to the right side. Take anything across your equals, the sign changes. So my 23x becomes a negative 23x. My negative 72 becomes a positive 72. Combine together like terms. 6x minus 23x is negative 17x. Plus 72. This factors using the PSD method. Factors as x minus 8 times x minus 9. Set 0 factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x minus 8 equal to 0 and x minus 9 equal to 0. And we get x equals 8 and we get x equals 9, maybe. Remember, step 4 is we have to check those answers. If I put 8 and 9 back up here, 8 plus 6 is not 0, 8 minus 5 is not 0. If I put 9 up here, 9 plus 6 not 0, 9 minus 5 is not 0. And since this here in the middle is a product of the other two, I don't need to check them. So our two answers are 8 and 9. Now that was the last rational equation. Technically, now we got some formulas that we're going to take a look at. So let's refresh your memory on the steps for solving formulas. They do fall under the realm of rational equations because you got variables and the exponents. But let me write the steps down. Solving formulas for a variable. And our first step is to get rid of parentheses. Our second step is to get rid of fractions. Now we'll get rid of fractions the same as we did before. We'll multiply everything by the LCM of all our denominators. Step 3. Get everything with the variable we are solving for on one side, everything else on the other side. So everything else on the other side. Step 4. If the variable we are solving for is in two or more terms, factor it out. And step 5, divide both sides by what is in front of slash back of the variable we're solving for. Let's take a look at our first problem here. Got A is equal to B over C, and we're solving this for C. First step, get rid of parentheses. Don't have any. Second step, get rid of fractions. I do have a fraction. We only have one denominator, the C, so that is our LCM. So we'll multiply both sides by C. So we've got C times A and C times B over C. Right here, the C is going to cancel. Now C times A, we just put them next to each other in alphabetical order, so that'd be AC equals B. Step 3, get everything with the variable you're solving for on one side, everything else on the other side. We're solving for C, everything with the C's on the left side and everything else is on the other side, so that's done. Step 4, the variable we're solving for is in two or more terms, factor it out. It's only in one term. Terms are separated by pluses and minuses. Step 5, divide both sides by what is in front of slash back of the variable we're solving for. We're solving for C. There's an A in front of it. So we're going to divide both sides by A. And those A's cancel. And we got C is equal to B over A. And that's our answer. Let's look at the next problem. We got A is equal to 2B plus 3C over D minus 4E, and we're solving it for B. First step, get rid of parentheses. Don't have any. Second step, get rid of fractions. I do have a fraction. We're going to need to find the LCM. Well, there's only one denominator, so that is our LCM. So we're going to multiply both sides by D minus 4E. So multiply times the A. And we'll also multiply it by the fraction on the right side. Now over on the right side, the d minus 4e's cancel. Over here we got a times d, which gives you ad, minus a times 4e, which gives you 4ae. Again, put them in alphabetical order. Now multiplying these together are very simple. The different variables, you just put them next to each other in alphabetical order. And then equals 2b plus 3c. Now we want to get everything with the variable we're solving for on one side, everything else on the other side. We're solving for b, as in Bill. So I'm going to take the 3c over to the left side. So we got ad minus 4ae minus 3c equals 2b. Step 4 we don't have to do. It's not in two or more terms. Step 5, divide both sides by what is in front of / behind the variable you're solving for. Solving for b, there's a 2 in front of it, so we'll divide both sides by 2. And when we do that, those 2's cancel. And we get b is equal to ad minus 4ae minus 3c all over 2. And that's our answer. Let's look at number 9. We got a equals to b plus c over d plus e. And we're solving for d, as in David. Okay, first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. I only have one denominator, so that is our LCM. So we'll multiply both sides by d plus e. Now over on the right side, the d plus e's cancel. Over on the left side, we got a times d, that gives us ad, and a times e, that gives us ae. So we got ad plus ae equals b plus c. Step 3, get everything with the variable you're solving for on one side, everything else on the other. So I'll take the ae to the right side, and we get ad is equal to b plus c minus ae. So we got everything with a d on one side and everything else on the other side. Step 4 we don't have to do still. Step 5, divide both sides by what's in front of / behind the variable you're solving for. Solving for d, there's an a in front of it, so we'll divide both sides by a. We'll do that, those a's cancel. And we got d is equal to b plus c minus ae over a. And let's start a new page. And let's look at the next problem. So we got 2 over a equals b over d plus e over f, and we're solving it for f. Okay, first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. Since I got 3 denominators and they're all different letters, your LCM is just the 3 multiplied together. So it'd be ADF. And that's what we'll multiply everything by. So we'll multiply it by the 2 over A. We'll multiply it times the B over D. And we'll multiply it times the E over F. Well, over here the A's cancel. Here the D's cancel. And here the F's cancel. So we're left with DF times 2. That gives us 2DF. Here we got, and I'm putting them in alphabetical order. So you got A times F times B. That gives us ABF. And over here we got A times D times E. So we got plus ADE. Now we're solving for F, so we want to get everything with an F on one side, everything else on the other side. So I'll take the ABF over the left side. So we got 2DF minus ABF equals ADE. Step 4. If the variable you're solving for is in two or more terms, factor out. It is in two terms. Terms are separated by pluses and minuses. So we're going to factor out an f. And that gives us 2d minus ab equals ADE. Last step. Divide both sides by what's in front of / behind the variable you're solving for. Solving for f, there's nothing in front of it, but there's a 2d minus ab after it. So we're going to divide both sides by 2d minus ab. I'm going to do that. These 2d minus ab's cancel. And we got f is equal to ADE over 2d minus ab. And that's our answer. Let me grab a drink and then we'll go ahead and do this last problem. Okay. We got A is equal to B plus C over B plus D. And we're solving this for B. Well, first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. I do have a fraction. Only one fraction, only one denominator, so that is our LCM, the B plus D. So we'll multiply both sides by B plus D. When we do that, the B plus D's cancel over here. A times B is AB. A times D is AD. When you multiply those together, again, very easy. Just put them next to each other in alphabetical order. And over here we got B plus C. Now our next step is to get everything with the variable we're solving for on one side, everything else on the other side. We're solving for B as in Bill. So I'm going to get all the B's on the left side and everything else on the right side. So I take the B over the left side. Remember, you take anything across your equals, your sign changes. It becomes a negative B. And I'll take the AD to the right side and it becomes a negative AD. Step 4. If the variable you're solving for is in two or more terms, factor it out. And it is in two terms here. So we're going to factor it out. Now when we factor it out and it appears like everything's gone here, you're always left with a 1. So just remember that. If you're factoring it out, it looks like everything's gone. You always put a 1 in factoring. Last step. Divide both sides by what's in front of / behind the variable you're solving for. Nothing in front of the B, but there's an A minus 1 after it. So we're going to divide both sides by A minus 1. And when we do that, these A minus 1's cancel. And you got B is equal to C minus AD over A minus 1. And that's our answer. And that's actually the end of that section too. So let me go ahead and save it.